Alright, today's video is all about percent of error, and these are the materials you're going to need: your spiral notebook and calculator, of course a pencil. Go ahead and go into your notes section of your spiral notebook and start jotting down these vocabulary words and recording the definitions here. Now these are just my keywords to remember what it means. You certainly can add to that or change your definition if you feel it needs. I really want to talk to you about what this concept is all about while you're writing down those vocabulary words. Think about those products that you purchase in the store, or really anything out there that you go, it doesn't have to be food, it could be, I don't know, shoes, or I don't know, nothing else comes to mind. But here I have a package of Oreos, and on this package it says that this weighs 3.5 ounces. If you think about how these things are made, they have a factory with a big conveyor belt, and the product rolls down the conveyor belt, and people are putting them into packages, or machines are dropping them into packages, sealing them shut and moving on. Are they exactly sure that this definitely weighs 3.5 ounces? It says it on the package, but if you put this on a scale and actually measured it, would it be exactly 3.5 ounces? Probably not. Because these goes through a big manufacturing plant, this is going to be an estimated size. It's going to be approximately 3.5. Maybe the machine had a little glitch and it has a little less cookies in it. So maybe it's a little bit less than 3.5 ounces. Or maybe it's a little bit more than 3.5 ounces. The machine put a few extra cookies in this container. This is an estimated weight. Because of how things are manufactured, you can't be exactly sure. That's what percent of error always is. Well, this is what it says it's going to be. What is it really? And what's the difference, or the percent of difference between what really is versus what it's supposed to be? Okay? So here is the formula that you're going to be using over and over again. And these are really kind of fancy words, but what we're trying to say is, gosh, what does it say on the package? This says 3.5 ounces on the package. But if I weighed it, what would the actual weight of this package be? You're going to subtract those two values. Maybe if you weighed this, it actually weighs 3 ounces. So the difference there would be 1/2 ounce. You're going to divide that by the actual amount, which was 3, and then times it by 100. And that's the percent of error. It's not exactly 3.5, but what percent of error is there? Now, if you're working or owning a manufacturing plant, you're going to want your percent of error to be very small, because your customers are going to be pretty concerned if they get cookie packages that are consistently less than 3.5 ounces. If you pay for 3.5 ounces, you want 3.5 ounces. So you want your percent of error to be fairly small. Okay? Now, here's an example, and I'm going to go through this one with you and another one, and then I'm going to have you try one on your own. Okay, Joshua is actually using his thermometer and finds the boiling point of ethyl alcohol to be 75 degrees. He actually does the measuring, and that's what he gets. Well, the reference book says that the actual boiling point is supposed to be 80 degrees. So what happened? Why wasn't it exactly 80? There was a percent of error. Maybe when he was actually looking at the thermometer, he had a slight angle on it such that he didn't read it clearly, or maybe he didn't put it all the way into the water carefully enough, or maybe the water is distilled or changed in some way. Maybe it has a chemical involved in there that's kind of altering that temperature. There is an error. There's a difference between what it's supposed to be and what it actually is. So what is that percent of error? How far off really was Joshua in percentage form? So what we're going to do is you're going to take how much is it supposed to be minus how much it is. You're going to take that and divide it by what it is, and then times by 100. So if you do 80 minus 75, you get 5. If you grab your calculator and divide that by 75, you got it? Now times it by 100, you get a very long repeating decimal, but it is roughly 6.7% error. So Joshua was off by about 6%, or close to 7%. That was his error. All right, here's another one. Chase worked in a lab helping pack material that was labeled to weigh 15 ounces. The actual packaging said it was going to weigh 15 ounces. Well, one of his boxes came off the conveyor belt, and it was weighed, and it actually weighed 14.5 ounces. So that's a little bit small, isn't it? what was his percent error? Now remember, if you're a worker in that company, you're not going to want to have a very big percentage error. You might be fired. So let's find his percent error nearest to the 10th. So we take what is it supposed to be minus what it is, divide by what it is, and times by 100. And you should get 3.4%. Go ahead and pause the video and actually punch those numbers in yourself and see how it all works. Did you get about 3.4%? That is a rounded number. Remember, we're going to the tenths place. All right. I'm going to have you try one on your own. Do take a moment to pause the video and copy the example down, and then give it a try on your own. And then come on back and we'll go over the rest. All right. Ariel weighs an object on her balance and recorded a mass of 24.3 grams. All right. The actual object is supposed to weigh 24.5 grams. What is the percent error? There is a difference there, but it is very small, isn't it? So Ariel is going to have a very small percentage error. If this was her job, this would be really good for her because it shows that she's being very accurate. So let's see what we do. You should have done what is it supposed to be minus what it really was. Divide that by what it was and times by 100. Make sure you do it in that order. Subtract first, then divide, then multiply. You should have gotten a rounded answer. Oops, I can write that a little bit better there. 0.82%. So it's less than 1% error. Ariel did a great job and was very accurate in her measurements. When you come back to class, we're going to do some more examples like this. Word problems, and we're going to go back to that formula every time. So if you need to rewind the video, go ahead and do so. Make sure you have the formula written down. And I would have jotted down some key, you don't have to write the entire word problem, but go ahead and write down the key points and then show your examples. So when you come to class, you have that as a reference point for yourself. I'll see you soon.